So now that we've learned that, we're going to work with right isosceles and radians. So draw a right isosceles triangle. And instead of labeling your angle theta, label it 45 degrees.
And your opposite angle, 45 degrees.
Yes. And now do your x and y, the square root of 2 over 2.
And your hypotenuse, 1.
So every point on the unit circle where you hit a 45-degree angle, so you're going to have 4 of them, your x and y values are the square root of 2 over 2. And depending on what quadrant you're in, depends on if it's positive or negative.
So first, draw your axes, so like your x and y axes, and label them your first, second, third, and fourth quadrants. So based on what Emily just said, this is all going to be positive. Your x and y values are both going to be positive. Here, your
X is negative.
X are negative and your y's are positive. Okay, and then over here, these are both going to be negative.
Mm-hmm.
And then in the fourth quadrant, your x are positive and your y's are negative. Does that make sense?
Yeah. So now looking at your right isosceles, find the sine of the 45-degree angle. With sine being opposite over hypotenuse.
Like over 1.
Over 1.
Yeah.
So then it just
And
be
then
this.
Square root of 2 over 2.
Yes.
Yeah.
Now find the cosine of 45 degrees.
It's equaling the same thing, right?
Mm-hmm.
Yes. Because for 45-degree angles, your x and y's are always
Square root of 2 over 2. They're always going to be the same.
Okay.
So,
next triangle.
yep. Okay, so now you're going to draw an equilateral triangle. So that's where like all your sides are the same. And each of your sides is 10. And all of your angle measurements are 60 degrees. Okay. And so based on that, when you split that equilateral triangle in half, what is going to be this? What is going to be your new value over here? So like split 10 in half.
So yeah. So if all that's 10,
What's half of that?
5.
okay.
So like it'll be like 5 and then 5.
Mm-hmm.
Yes. So if this angle was 60, what is the new angle up top?
Like where?
Like each of these little angles. If this
So-
whole one is 60, what's half of those for each one?
30.
Yeah. So you can draw a new one if you want to.
Yeah.
So now you've dealt with 30 degrees, 45 degrees, and 60 degrees.
Your hypotenuse, you're gonna find, using the Pythagorean theorem, you're gonna find not the hypotenuse, but the this of
X
it,
and Y's.
the x and y's. So based on this being your 60-degree measurement, find. Actually, I don't know if that would probably work.
So plug the values you have into the Pythagorean theorem. So a squared plus b squared equals c squared.
And we have c
You
squared,
have-
which is 10.
And you have a. So 5 squared is,
25.
and 10 squared is, 100.
Just make sure that's squared still.
So when you subtract 25 from 100, so now because this is squared, you have to square root your number.
Mm-hmm.
Get rid of the square. So square those. And then
And you don't want decimals. Haha! Okay, so new trick. What two numbers can you multiply to get 75? How many quarters are in a dollar?
4,
And how many of those make 75?
3.
okay, so 25 times 3 gives you 75.
Yeah.
So if you make a tree,
Just like
your little, yeah.
25 times 3 will give you 75.
Can you break 3 down anymore?
No.
Because it's a prime. So
Mhm.
circle that one. Can you break 25 down anymore?
No.
Wrong.
Wrong.
It's a perfect square. So 5 times
Oh,
5 is 25.
Yeah.
So if you make another tree, you can do that. Okay, so whenever you have two of the same number, you're going to take those out of the square root. And whatever you have one of, it's going to be inside your square root. So this whole thing,
So it'll be like.
Yeah, 5 to the square root of 3.
yep. So that's done. Now we're going to go on to the actual unit circle. Because, well,